Pattern faults are a patented fault modeling technique unique to Modus. Basically, the required stimuli and expected responses are defined in terms of static values or transitions on the pins of the structure to be tested. When the pattern fault is selected by test pattern generation, the test pattern generator sensitizes the fault by applying the required values and transitions to the input nodes of the structure and propagating the resulting values at the output nodes to observation points. See MOS-MUX, with Pascate's example is shown here, in which internal selector defects can cause high Z or contention. It is not detectable by cell pin stuck at or transition test, and not detectable in an OR equivalent circuit internals. Pattern faults detect inner circuit defects. This slide shows the features and goals of the pattern faults. Pattern faults can help fill in where the standard static fault model doesn't represent the true transistor level faults. Simple cell level fault model is inaccurate for technology cells with internal fan-out or Pascates, such as latch. Transistor level modeling would be inefficient to represent true transistor level faults. Pattern faults allow specific test sets to be applied. Provides better defect coverage. Comparisons excluding pattern faults are ignoring a unique differentiator of the product. The true target is to increase defect coverage and minimizing test escapes. This shows what pattern faults consist of. Simple pattern fault consists of conditions required to activate the defect. Single value for static faults, value pair, initial or final, for dynamic faults. Pin or net, and good or fault machine values for fault propagation. Complex pattern fault consists of multiple simple pattern faults. O-red pattern faults imply the defect is present when any of the simple pattern faults are detected. AND pattern faults imply the defect is present when all of the simple pattern faults are detected. Pattern faults allow the tool to model defects that are not modeled by the traditional stuck-at or transition fault model. For instance, a bridging fault between two nets may be modeled by specifying stimulus values at the output of the gates that source the nets and expected values at the net sinks. This is a very powerful and general capability that allows many different situations to be described in a way that test patterns can then be generated. It is used to generate patterns for path delay, bridging defects, crosstalk, and diagnostic fault isolation. It is also used to generate optimal patterns for complex cells, where the AND or equivalent circuit would give suboptimal results. Pattern faults can be defined for any object that can appear in a netlist. Anytime that object is instantiated, the pattern fault will be included in the fault list.